Hello students, welcome to our second video on Chapter 8, Project Management. We're going to look at an activity or a project that has multiple times. So times are listed in this column, these columns here. Let's color these. These are the optimistic time, denoted as A, most likely time, denoted as M, and the pessimistic time denoted as B. So we need to calculate an average or expected time. We do this by using the following formula. It's a weighted average calculation. It's going to be A plus 4 times M plus the value in B, and we're going to divide that by 6. And that is our formula, our weighted average calculation for the expected time for activity 1. We can copy, drag that down, and there are the project times. To calculate the variance, we're going to look at the difference between the pessimistic and optimistic times, and we're going to divide by 6. And then we're going to square that value, so it's the value of 10 minus d to the value of 6. We're going to first divide by 6, and then we are going to square that. And there is that variance for that activity. And we can drag this down. Those are the values you should be getting. Now with this project we have the 11 activities listed here. Let's show that in a different color. And the time. So we're going to develop our project diagram using the activities 1 through 11, the predecessors, and the expected time, the time value in column G. So I'm going to go into a Jamboard and draw this out. So we have, this is 11 activities with quite a few predecessors here. So we have, that's where we're going to start. We have 3 activities that can start at the very beginning. So we have activity 1, we have activity 2, and down here we would have activity 3. It says that activity 4 happens after activity 1. And then activity 5 happens after activity 2. And activity 6 right after activity 3. That information is from the spreadsheet we're looking at. We have done the first 6 right there. These other activities, especially activities 8, 9, and 11, you can see that they have multiple predecessing activities. So those are going to be a little tricky to draw. So activity 7 also happens after activity 3. We're going to extend this a little bit just for the purpose of our diagram. There's activity 7. Activity 8 occurs after activities 1, 5, and 6. So let's put this one right there. We've got to draw these lines roughly straight. That's not very good. 1, 5, and 6. So that means that activity 8 can only happen after all the activities 1, 5, and 6 are completed. Activity 9 likewise occurs after activities 1, 5, and 6. So let's draw it out this way. And then activity 1, kind of drawing this as straight as I can. Not bad. There's activity 6, or activity 9, happening after activities 1, 5, and 6. Activity 10 happens after activity 4. So I'm going to stretch that out a little bit. There's activity 10. And then activity 11 right at the last activity, occurs after both activity 7, 8, and 9. Let's just draw that little pointing arrow. There we go. And then because there's two activities that basically just wrap things up, let's just put this one going to being designated as the last activities. So those ones are complete. Now, I will do the earliest times based on the projected time. So back in our project guide here, we have activity 1 with a time period of 8, activity 2 with an expected time of 6. We're going to draw this in now. Zero and 8, 0 and 6, and then activity 3, 0 and 3. Well, activity 4 only has activity 1 as a predecessor, so this will be a time period 8, and it will go till time period 13. Activity 5 occurs after activity 2, has a time period of 3, starts at 6, ends at 9, and then activity 6 has a time period of 4. So this would be 3 down to 7. Activity 7 we can complete. Time period is 2. So this is going to start at time period 3 and go till time period 5. So now we have to do these middle activities, activities 8 and 9. Activity 8, the earliest activity 8 can start by is after activities 1, 5, and 6. So activity 1 finishes 8 at a time period 8, but activity 9, or activity 5 I should say, finishes at 9 weeks, whereas activity 6 finishes at 7 weeks. So activity 8 has to start after all 3 activities are completed. So that means activity 8 can only start at a time period 9. Same thing with activity 9. Predecessors are 1, 5, and 6. So the earliest I can start by is at time period 9. If it starts at, say, time period 7, which is when activity 6 would be completed, activity 5 is still not completed, nor is activity 1. So that's why activity for the predecessors is the maximum time for all the earliest finish times. Let's go and complete activities 8 schedule. It's going to last for 7 weeks, so that's time period 16. Activity 9 lasts for 4 weeks, that's 13. And then we're good with that. Activity 10 only occurs after activity 4, and that goes for 4 weeks, so that's 13 to 17. Activity 11 has to start. The earliest it can start is after activities 8, 9, and 7 are completed. If we picked time period 5 for activity 11, activity 8 and activity 9 are not done yet. So activity 11 has to wait until all predecessing activities are completed. So that's why activity 11 is going to have, it will start, the earliest it can start is time period 13. And that goes for, 16. Forgot about activity 8 up there. Hopefully in the video you caught that as I was doing that. So activity 8 finishes at time period 16, whereas activity 9 and activity 7 are both completed, but activity 11 has to wait until all activities are completed. So we have activity 11 going for 9 weeks, that's 25. And so the ending time would be the maximum time there. So the time for this activity, or for this project, is expected time is 25 weeks. Let's calculate the critical path. Critical path, we're going to start at the project time for both last activities. So that has time period, or activity 10 has time period 4, so that's going to be 21. Activities 8, 9, and 7, the latest they can finish is in enough time for activity 11 to start by. So this one, because there's only one activity before them, is 16 for all of these. Activity 8 has a time period of 7. Activity 9 has a time period of 4, so that would be 12. And activity 7 has a time period of 2, so that's 14. Activity 4 basically has to finish by in enough time for activity 10 to start. So activity 4 would be 21. And the latest it can start is time period 16. Activities 5 and 6, the latest they can finish is in enough time for activities 8 and 9 to start. The latest they can start. So that we look at the smallest numbers here. So it's 9 and 12. So activity 5 and activity 6, the latest they can finish is time period 9, because the next activities have to start. Activity 8 has to start at 9. So then the latest activities before this would have to be able to finish by would be that time period. So we have 6. In this case, we would have 5. Activity 1 would be 12. Would be 9, because it has to finish in enough time for activities 1, 8, and 9. So this one would be 9, starting at 1. This one has to be 6, because there's only one activity after that. And activity 3, they could finish at 5 or 14. So to keep things kind of on schedule, activity 3 has to finish by time period 5 in order for activity 6 to start by. So that's going to be 2 there. So our critical path are those activities that do not have any difference between the earliest and the latest times. So we'd have activity 2, 5, 8, and 11. So what we can do is go back to our schedule, and we know in order to calculate the project variance, we're going to add up all the variances for the critical path activities. 2, 5, 8, and 11. Gives us a variance of 6.889. One thing we can do with this, let's go to a clean chart, is we can we assume that this follows normal distribution, so we can go through a question like this. What's the probability that the project takes less than 23 weeks? So in our project, we assume it follows normal distribution. The average is 25. The standard deviation is the square root of 6.889. And then we can calculate using our normal distribution process. 23 for x, average is 25. The standard deviation, I'm just going to put this in here. Calculate this quickly. 2.625. 2.625. So we want to know that it is less than 23. No, let's change that to be probability that's more than 23 weeks. There's 23, and we want all of this area here. So this is a two-step process. Z equals 0.76. Look at the normal distribution chart, which I have right here. Normal distribution chart gives us a Z value of 2764. So we can write this down here, 2764. This number here is from the middle outward, so it's this section in here. This right in here is 2764. This part over here is 0.5, so the answer is going to be 2764 plus 0.5, 7764. So So 77% chance at finishing more than 23 weeks.